Okay, so if you're a graduate student in the sciences, and you're looking to have a career in research, your number one priority should be to get published. So I know everyone's concerned about grades and everything, but once you graduate and start looking for a postdoctoral position, it's your publication record that's going to count a lot more than your grades. So let's start off with what qualities actually make for a good scientific paper. And the first one is clarity, which would seem obvious, but science is complex. You're dealing with many times awkward terminology and processes that can be difficult to describe. You're trying to describe mechanisms in space and time and a lot of complexity. So achieving clarity takes some experience. And some of that you can gain through reading. As you read really good papers that get complex ideas across clearly, you can learn from that. The second quality is brevity. Short and sweet is always the best. So in the course of trying to describe complex phenomena, you end up with very complex explanations. And so part of the challenge of getting to a good paper is simplifying those explanations. And the shortest explanation is always the best. And finally, novelty. If you don't have something new to say, you don't have a scientific paper, okay? So most of what I'm going to say today relates to an empirical study. So something where you're producing new data, okay? But even if you're writing a review paper, okay, let's say you're going to have sift through a lot of data and write a review paper, well, you better have some new inferences. In other words, that review paper better be more than the sum of its parts. You better have some new conceptual inferences if you're just going to talk about other people's already published data. I'm sure you're all familiar by now with the general structure of a paper and its different parts. Sometimes you'll see results and discussion merged together. I don't care for that. You know, for most purposes, it's better for you to learn how to do a good results and discussion separately. More recent electronic or digital only publications, you'll even see the materials and methods presented as a sort of a supplementary or an appendix. But in general, this is the type of structure you're going to face for most papers, and so I'm going to discuss the different parts in this sequence. Deciding on a title. This is a very important thing, okay? Some people might only ever see your title in a database search, and you want all those people to be interested enough to go and at least click on the abstract, or hopefully read the whole paper. So the objective is clearly and concisely identify what the whole paper is about. Seems obvious, right? Well, easier said than done. You see a lot of really bad titles out there. In fact, more than half of them are actually really bad. These are published papers. Look how many of them use the words effects or influence as the subject in the title. Don't do that. If you have if you didn't have effects or influence of something, you wouldn't have a paper, would you? Okay. The other bad thing about using these types of words as subjects in the sentence of the title is they force you into a passive voice. Okay. Now there's plenty of decent titles out there that use passive voice, but if you can come up with a title in active voice, it will always have more impact. Okay. Try to make the subject of the study the subject of the title. Okay. Very often this will be an organism's name, for example, but use the common name. Don't use just a scientific name, because a lot of people who might have peripheral interest in your topic might not recognize that scientific name. And don't try and include too much detail in the title. That's what the keywords are for, okay? So the keywords index the terms that are not mentioned in the title. So for example, you might have a community insect study in a field. You found dozens of different insects. You can't list them all in the title. So identify the ecological system and then put the key species names in the keywords. So let's look at some titles. These are ripped from the headlines. Most recent table of contents from Journal of Economic Entomology, as a matter of fact. 2 consecutive papers with really, really bad titles. So let's look at that first one. Well, first of all, if you're an entomologist, you probably know that Apis cerana is a bee, but it's a small solitary bee, so may not have a common name. We'll let them off the hook for that. But ignoring for a moment that misplaced preposition that really breaks the whole sentence and should have been caught by the editor, what is wrong with this title? Makes the same mistake twice. Anybody?
R?
So what?
Should it be Apis R?
No, what the problem is, they're in the comparative tense, okay? Less sensitive than what? Smaller than what? Okay? Don't ever initiate a comparative and then fail to provide the comparison, okay? So let's fix it for them. Apis cerana has low sensitivity to most neonicotinoids despite a small body size. See, that's what they really want to say. But they measured mass, so they put the mass in the title. It's better to say body size because, you know, the reason they measured the mass was to get the relative size of the insect. So the whole idea is better encapsulated in that second title. Let's look at one that's even worse, or at least as bad. Again, the effects, the title, okay? Megachila rotundata is the leafcutter bee that is important for pollination and seed production of alfalfa, okay? There's such poor information in this title. You have to go to the abstract to understand that what was really going on here, that the mosquito management was occurring in nearby urban areas, okay? And then in fact, they were looking at the drift of this into the alfalfa seed production fields, okay? But effects, I mean, look at the effects. It doesn't even tell you the direction of the effect. And if you go to the abstract, you find, in fact, there were no effects. It was very, very benign, okay? So they didn't even get the central finding of their study is not even represented in this title. So again, let's fix it for them. Put the common name. Most people have no idea what this is a leafcutter bee. Are unaffected by ultra low volume applications of etofenprox against mosquitoes. And again, larvae and adults, well, why do you even need to mention that? These are the active stages that are going to be exposed. Everybody knows that. And in an agricultural setting, well, really, this is misleading because it makes you think that the mosquito management is going on in the agricultural setting. And in fact, it's going on in nearby urban environments. So just leave that out. Anyway, I could go on all day with bad titles. Give me any journal pretty much. So the introduction. What do you want to do with the introduction? What is the purpose? What is the objective of the introduction? Anyone?
Introduce what you're
Sorry?
writing about. Introduce what you're writing about and state the objectives.
Correct. You want to set the stage. You want to lead up to your study, okay? So how do you do that? Well, an effective introduction does 3 things. Brings the reader up to date on the current state of knowledge on the subject. So you'll have a historical overview of what came before in terms of research on your topic, okay? You want to deal with that chronologically. It should also inspire interest in the topic. Okay, don't just collect all the references you can find on your study insect and, you know, pile them all together. You want to inspire some interest in the topic. And finally, and this is where many introductions fail, you want to lead up to the reasons that you did your experiment in the first place. Okay, you develop rationale for why you chose this study system and why you designed the experiments the way you did. So when I hit the materials and methods, I understand exactly why you did these materials and did these experiments, and I can focus on then on how you did them. So what you start with is review the development of the concepts in the field chronologically. So you start with your older references that might be still important today, and then you move up to the more recent ones. Address the topic initially in broad and general terms, and then home in on the specific study or system or topic that you're working on. So that means, for example, I've done some papers recently on limb regeneration, okay? So I start out talking about everything that's known about limb regeneration in invertebrates and animals in general, the type of studies that have been done. Then I home in on insects. And then finally, I talk about the work that's been done in my own group of insects, which would be coccinellids. Okay, so you go from the broad and the general to the specific. Then towards the end, you develop your rationale. Why you selected your study species, why you chose your experimental approach. That should be clear in the reader's mind before they start reading about your methodology. And if you can, and this is to really have a good introduction, should end with a series of hypothesis statements that predict the outcome of your experiments or the direction of the treatment effects that you expect to observe. And these hypotheses must all pass the Popper test. Anyone? What is the Popper test? Well, yes. They must be falsifiable. In other words, the outcomes of you must be able to say the data supports that hypothesis or it does not. So to be a good hypothesis, it has to be falsifiable. Okay? And it's okay to hypothesize things that turn out to be exactly the opposite of what you expect. You deal with that in the discussion. Okay? It's a more honest thing to do, is to have some hypotheses that are not supported. You don't know the results. And it's always suspicious when you see a series of hypotheses that are all supported, because it might suggest reverse engineering. Don't reverse engineer your hypotheses. So we get to materials and methods. The objective is to provide all information necessary for complete replication of the experiments by others. And I'm sure you've heard this before. And it's obvious, but it's harder to do than it is to say, like most of these things. And so it takes a lot of discipline. Materials and methods, it's all about organization. So the first question I'll ask you, though, is when do you write your materials and methods? When should you start writing your materials and methods?
As you're doing it?
Exactly. Don't assume you will remember all the little details that you did. So you should be writing your materials and methods as you're doing your experiments. That way you won't have scratch in your head. What did I do here? How many minutes did I leave that? You won't remember everything you did. So start with the essential background information. First paragraph should deal with where you did the study, if it's a field study, or where you collected your insects, your source materials that you used, and describe the preparatory handling of all your subject materials. Okay, how did they get to the lab? What did you start with, and how is it dealt with before the experiment was set up? In describing the experiment, start with the physical conditions first. If you have a lab study, you have physical conditions of the environment in which the experiment was performed. That might vary among experiments, but start with that, and you can modify it later. Otherwise, you can say all experiments were performed under these conditions, and you don't have to repeat yourself. Then move on to the design, the protocols, how many replicates and everything, keeping in mind that this is like a recipe, and that you have to be able to read through that and be able to reproduce all these experiments exactly. And keep everything chronological. It helps if you do this while you're doing your experiments, because you remember that you want to describe everything in the exact procedure that you actually did it. Okay, because that makes, for a recipe that can be replicated. And keep in mind, you might have a paper which combines the results of 4 or 5 experiments. So you can present those experiments in any sequence you want. But keep in mind, you've got to follow that same sequence of experiments in reporting your results. So sometimes you know that one experiment there is far more central than all the others, and you want to report those results first. Well, then describe that experiment first. So that is a case where you do reverse engineer from the results. You describe those experiments in the same sequence that you plan to report the results. Was there a question? Anyway, feel free to interject if there's a query along the way. So the results, the object of the results is to showcase your data. This is the most important part of your entire paper. This is the guts. This is really the nuts and bolts. This is what you've produced, okay? And you want to be as concise as possible in doing that. But really, this is the part of the paper that's really going to impress other scientists. One of my former supervisors, he used to say, this is where you dazzle them with your data. And so to do that, you have to be as concise as possible. A common mistake that novices make is to insert these interpretive statements. They're so enchanted by the results, they feel compelled to put interpretive statements after the reporting of a result, and don't do that. That's for the discussion. You report the observations and associated statistics as concisely as you can. And this is the most common mistake that most people make when they get started writing. You can only report that data once. Absolute values can only be reported once. Okay, so you see it, people have numbers in tables, or they'll have histograms, and then they'll repeat that actual numerical value in the text. You're not allowed to do that. You can talk about trends. You can have absolute values in the figure, and then talk about percentages or effects of treatments, or direction of the treatment effects as you report the results. But don't repeat the values, okay? The purpose of tables and figures is to get numbers out of the text and make it more readable. Strive for consistency in formatting, okay? And every level, and that encompasses a lot, that short sentence. For example, if you're going to report your F values to 2 decimal places, make sure all F values are reported to 2 decimals. And bringing up the question to decimal places, that's something I'm going to deal with in a minute too. Don't have to keep saying significantly different, okay? Different means it was significant in the analysis. And the flip side of that is don't refer to non-significant results as being different, because effectively they were the same, okay? You can talk about things being marginally significant if you have like 0.057 significance, let's say, but if it's that close in one way or the other, you should perform a power test of that p-value. So getting back to the decimal places, and the reporting, this is another thing. Do not devote a sentence solely to citing a table or a figure. You got to say something about it. This is another common mistake. So, for example, mean developmental times in all 4 treatments are reported in table 2. No. You're wasting a sentence just to cite a table. Say, developmental times of treatment 3 were significantly longer than those of other treatments, in brackets, table 2. Now you've said something about the data, okay? And you refer the reader to the correct source of that data. But how to report the data, that's the next decision, right? That's a big decision. Do you use tables, do you use figures, or you report values in the text? Well, figures clearly have greater visual impact, but they take up a lot more space on the page. So normally you're only allowed a few of them. There are a limited number of tables, okay? But they are best used to depict the most important results that you want to emphasize because of their greater visual impact. Tables, on the other hand, are suitable for much larger sets of data, okay? Sometimes you need to make large numbers of statistical comparisons that are really not feasibly accomplished in a figure. And they are also preferable when you want to have your data made available to for use by others in some sort of meta study, for example. People are going to want to use that data. They're going to want to have the exact values, okay? And nobody wants to have to try and guess the values from histograms in a figure. So if you want your data accessible to subsequent meta-analysis, you'll want to have it in tabular form. And finally, results that are simple or trivial are best reported in the text. Let's say you had 4 treatments of your insect. You had, let's say, I don't know, 4 different diet treatments, and survival was not significantly different amongst those treatments, so you don't want to devote any big space to survival data, so you just say the means survival did not differ among treatments, F-value statistics in brackets, and mean survival was, report the mean for the whole experiment, done. So simple or trivial findings are best reported in the text. Don't waste space on them. Now, we get to another issue. Meaningful number of decimal places. Only report the number of decimal places that are biologically meaningful. So let's, for example, think now of looking at developmental time of an insect, let's say, takes 3 to 4 weeks from egg to adult, and you're studying this life history. And again, maybe you're feeding on different diets that have an effect on developmental time. But you're measuring developmental time in days. How many decimal places are you going to report the means? Anyone?
Maybe 1.
Maybe 1. Why?
In case you have a half day.
Well, why would you not use 2?
That's not really that important, I wouldn't think.
2 hundredths of a day are not biologically meaningful. So you're asking yourself exactly the right question. You see, how many, if you're going down to 3 decimal places, ask yourself, are thousandths of a unit in this variable, are they biologically meaningful? If not, use the minimum number, use the lower number, because again, you want to minimize numbers and figure in the text. So you're just cluttering the text if you use those extra decimal places. And people who are, especially people who have been trained, statistically, they want to put every last decimal place. It doesn't help make the point. The other thing is, tables and figures have captions and legends associated with them. And they should contain all the information needed to understand that table or figure, including the methodology. And incidentally, species names should normally be spelled out in full in legends and captions. So I should be able to open your paper, look just at that figure or just at that table, and that caption should tell me everything I need to understand exactly what's going on in that figure. The discussion, of course, the purpose of the discussion is to interpret the results and place them in context, okay? Again, it's not just a collection of all the other references you found on your species. So, a common mistake is people will start out by discussing the previous work as if they were writing another introduction, okay? You're not. So start with your most important results first, and then use those references of previous works to provide context for your findings. You want to use only relevant citations. You might be working on, I don't know, European corn borer. There's thousands of references out there. You don't need to cite them all. You need to be very selective. You need to find those that either support, contradict, or provide some perspective for your findings. And try to, most studies are very focused. We all studied narrow little things of our system at one time. So we end up with narrow empirical observations, which by themselves are not going to be, that meaningful or interesting. It's your job as the writer to put those narrow empirical observations into broader contexts, okay? Why is it important? What does it mean for the ecology and life history of this insect in the field? If you did let's say even if you have a small lab study of behavior, what does that mean if we look at it in a broader context? What does it tell us? What ideas does it give us for other sort of work we should be doing elsewhere or out in the field? You want to be exhaustive about exploring alternative hypotheses that could account for your results. Now, it's only natural, natural human nature to have a preferred explanation for what you observe. And feel free to elaborate on it. But you need to think very carefully about alternative explanations, however unlikely, okay? Because it will, if you don't find them, some reviewer will. And then again, it'll make you look like you were not thorough in your analysis of your results. Avoid use of adjectives and adverbs, okay? Science likes understatement, not overstatement. And understatement is always more effective, okay? We had extremely high mortality in treatment 5. No. Treatment 5 yielded the highest mortality of all treatments in the study. Okay. Okay. So adjectives and adverbs are to be used sparingly. And also at the end, one of the things you can do is to suggest avenues for future research. Where to from here? Okay. There's not many times you're going to conduct a study and then look back and say, gee, I would do everything exactly the same. Okay, so you might suggest ways in which you could perform your own experiment better or repeat the research more effectively, or you might have some other ideas raised by your research that warrant further experimentation. So the end of the discussion is a good place to suggest that. But you really want to try and finish with a strong impact statement about the broadest implications of your research that you can. Because remember, that's going to be the last sentence in the text of your paper. So you want to make an impact with that. It's the last thing they're probably going to read. Now, a lot of findings are tenuous, and it's tempting to speculate. And there's a way of speculating that's allowed, and there's a way that isn't allowed. Okay? Speculation, again, is a natural human tendency. We worked hard, we got all these numbers, and we really want to make something out of them, okay? So you don't want to be categorical. So for example, I made a statement here that we can improve on. So we conclude that widespread use of pesticide X is responsible for disrupting biological control of aphids in the field because of its observed toxicity to beneficial insects in the laboratory. Now, that's obviously contrived. So I don't think anyone would make a statement that categorical. But it's illustrative to go through the exercise of saying the same thing in a way that's perfectly acceptable. And using the conditional tense will buy you a lot of latitude. Okay? So the second sentence is something that nobody could criticize. Okay? You see that first sentence, if you put that in there, some reviewer will jump all over you for that. But they can't do it if you word it in the conditional tense. So if the observed toxicity of pesticide X to beneficial insect holds true under field conditions, then it is unlikely to be compatible with biological control of aphids. See, I flipped the whole second half around. Rather than saying it's likely to be toxic to beneficial insects, and that is a way that you can lead the reader to the conclusion that you want without shoving it down his throat. Many results are tentative, and they do not warrant sweeping conclusions. But if you use conditional inferences carefully, you can lead the reader to the desired conclusion, okay? Instead of saying, this is what it all means. Nobody wants to be told what to think. But if you gain experience in writing an effective paper, you can lead them to the inferences that you want them to make. That's a skill. Takes a little experience. Now we come to referencing. You want to list all directly relevant literature which either provides historical context to your work, and that would be done in the introduction, and also aids in the interpretation of your results, which is ones that you would cite in the discussion. And of course, you have to ensure all citations that you make in the text are listed in the references and vice versa. Now, the easiest way to do this, I find, as I always begin an article with the references in a completely separate file. Okay? And that way, at the end of the paper, I can go through and check every reference in the text, and as I find it in the text, I go and highlight it in the list, and I know I have it cited. And if I end up with any that aren't highlighted, I know I have to either delete them or go back and cite them somewhere. Okay? You want to keep careful track of references as you read. Now, if you're one of those people who likes to cut and paste passages of text from articles as you read, make sure you copy the reference with them. You don't want to accidentally or inadvertently plagiarize something. You might forget that that was from a paper and think that you wrote it yourself. We've seen that happen. And so don't accidentally plagiarize yourself. The other thing is, make sure that each reference really supports the assertion you attach it to. And as an editor, I'll read through, and if I see a familiar reference miscited or cited as evidence of something that it really isn't, then all of a sudden I don't trust you. I don't trust any of your referencing because you're not careful enough. Okay? You want to engender the trust of your reader, your reviewers, and your editor. So don't do sloppy things. And the other thing, don't string a whole bunch of references together in long lists. So, the European Corn Borer is a pest in countries A, B, C, D, E, E, 5 references in brackets. No. Maybe I'm interested in only country D. I don't want to have to go through 5 abstracts to figure out which reference refers to that particular country. Each reference should go after the country in which it supports. Okay? And I'm old school. These things weren't around when I was a grad student, but these referencing tools like RefWorks and EndNote are very useful aids, and you should take advantage of them. I believe RefWorks is free through K-State libraries, and it's a really convenient way to help you download and organize your references and download them even in different formats for different papers. But even then, you want to go through and make sure that all your formatting matches that of a recent paper from the journal you're submitting to, because these don't count on these automated services to give you exactly the right punctuation and so forth in their citation of references. You want to check that against your guide to authors. Now, acknowledgments are really simple. You thank and you leave. You want to make sure you list all of those who help with the data collection analysis. Anyone who's not listed as an author, don't list authors. They've got their authorship, okay? Make sure if it was work that was done in your institution that it carries this appropriate institutional accreditation. In the case of work that you would do in entomology, it would have a Kansas Experiment Station number. And don't try to be cute, funny, or long-winded. Short and sweet, you thank and you leave. So finally we come to the abstract, which is probably the last thing that you write in the paper, but it's one of the most important. And it's really important because when we think about how many, scientists are reading through databases and don't go any further than the abstract, it could very well be the only thing that many people will ever read. Okay, so you want to spend a lot of time on that. Edit it, re-edit it. Don't include references or statistics generally in the abstract. Try and keep numbers and just try and summarize the main effects verbally. And stay in the past tense. I could have put this there in the results section too, but don't change tenses in the middle of the sentence and stay in the past tense throughout. There are a few exceptions where you're perhaps discussing a very well-recognized concept in the discussion. You can use the present tense. Okay, but in general, in your reporting results, whether in the results or in the abstract, consciously make an effort to stay in that past tense throughout. So the object here is to summarize the key findings of the research. Now, if you went back a number of years, you would find that there are 2 kinds of abstracts generally. There were descriptive and informative. So in the old days, people used to produce these rambling treatises and long monographs and so forth that couldn't possibly be informatively summarized in an abstract. So the abstract would describe, you know, what sort of system was dealt, what sort of questions and experiments were performed, but it wouldn't provide you any information about content. Well, you don't see those anymore. So we want to focus on an informative abstract, okay? And it's hard, you're often limited to just 250 to 400 words. Boy, you've got to choose those words carefully. You've got to introduce your study system and experimental objectives. Briefly describe your essential methodology. 2 sentences maximum. Just the absolute minimum for the reader to grasp what you did and why. And a very concise result statement should form the most of the body of the abstract. And again, they're not cut and pasted from the results. They're condensed into a much shorter format. The abstract should also be understandable to someone outside your field. Okay? So avoid jargon that's only someone within your field would understand. And the end of the abstract should finish with the broadest conclusions and the biggest implications of your work. Okay? Which brings us to peer review. And our favorite part of the whole publishing process. And what you should really do, especially as you know, as a novice author, is you should seek out the best peer review you can find before you submit. Okay, the journal is going to have your paper reviewed for their purposes to make sure it's of sufficient quality to protect their interests. Pre-submission peer review is something you do for your benefit. It's to improve the manuscript and its chances of acceptance. And of course, there's 2 kinds of reviews, generally speaking. The rubber stamp, which is useless. I'm an editor, I get one of those. Oh yeah, accept minor changes or accept no change. I just throw them out and I get another one, okay? There's always room for improvement. So if someone comes back to you and doesn't give you they didn't do a good job. You want a review that finds the problems that you can fix before you submit it. So what does a good review do? Increases clarity. So by the time you write your paper, write up all your research, you're far too close to that work, okay? You spent so much time on it, you know everything that went on. You're too close to it to recognize things like ambiguity, sentences that might be interpreted more than one way. Believe me, I still do it. I leave in ambiguities because I already know what I want to say. And I don't recognize, as a third party might, how that could be interpreted in more than one way. Okay, happens to the best of us. It also, a good review, that person will be familiar with the literature. They might be able to point you to a couple of articles you didn't recognize or you didn't know about, or maybe you forgot to mention something that would be very pertinent and help your research should have a better interpretation. So someone is going to come in with knowledge and a third-party view of your work. They're going to help you correct these things, because when you submit, you want that paper to be in the best possible condition. If these types of problems are identified by the reviewer post-submission, it's embarrassing. Where, you know, if you get, it's much better to catch them before you submit. And proofread carefully. My God, even spelling mistakes count. Think about it. I mean, as an editor, we get submissions. Sometimes I've even seen a spelling mistake in the species name in the title. What kind of impression do you think that gives? You say it's only a spelling mistake, but it tells me you're not careful. And if you're not careful about spelling, what else are you not careful about? Your data collection, your procedures, your analysis. You see? It's like showing up to work with a big black smear on your face. You know, you wouldn't do that. So be very careful. I cannot impress upon you how much those little things affect how your paper is going to be received. Remember, the editors are all overpaid and underpaid and overworked. And every single paper is another chore. So if you give them an easy excuse to reject you, they'll take it. Now, you've gotten back your reviews. This is the point where you have to not take things personal, okay? You got to expect that some criticism is going to be justified, in which case you welcome it because your end result is going to be a stronger and better paper, and some is going to be unjustified, and it's going to irk you, and you're just going to get fuming mad as you read it. So that's why once you read all your reviews, okay, put the paper away for a few days. Come back, let them, and you will have a much more relaxed and rational approach to dealing with those criticisms. And deal with those comments one by one in an itemized list. So the idea here, you want to make the editor's job as easy as possible. Don't, make it very clear what you did, and don't leave any comments unaddressed. Sometimes if I get a tough series of reviews, I will spend more time answering or rebutting reviewer comments, as much time or more, than I spend revising the manuscript. Because I want to spell out to the editor exactly why, I've done this and exactly why I'm not doing that, and justify it. So within the manuscript, I like, they'll always say mark all changes. But don't use track changes for this. It's far too messy. It's fine for editing and reviewing track changes. But when I resubmit the manuscript, I will usually put all changes to the text in a different font color. So again, you want to make it easy for the editor to go and see what you've done. And if you want the editor to be your friend, you have to make their job easy. And don't be afraid to challenge or rebut unjustified comments, okay? Because you will get them. And for example, maybe you're ambitious. You want to submit to an ecology journal, okay? So you better have a broad implications of your research, but at the same time, be prepared to be reviewed by non-entomologists. And very often they'll say things that make no sense at all. Don't get upset. Don't take it personally. Make a detailed explanation as to why this comment is mistaken, or indicate exactly where the reasoning is flawed. And we all get rejected. It's just part of the process. Sooner or later, we all get rejected. And you don't quit, okay? In fact, you'll get some very good reviews that will strengthen the manuscript. And I would say a significant proportion of rejected manuscripts go on to be published somewhere else. But they're improved as a consequence of the reviews that were received in that first submission. Now finally, just some general tips about writing, okay? Develop good writing habits. You have to make writing a part of your daily routine. That means finding your time and your place to write, okay? I'm an early bird. I'm up at 4 in the morning, and I don't write at night. Some other people are night owls, and that's their quiet time and place. You might have a wife and 3 kids at home. That might not be your place to try and write. I like to write in my office, not because I have any distractions at home, but because I have all my reference library here, and I like to have it on hand if I'm looking for reference. So you got to find time and a place where you can focus on your writing. And reading is a parallel process, okay? Thinking back, I would say for every hour I spend actually writing, I probably spend 2 or 3 hours reading, okay? Not in separate times, but I'll get sidetracked looking for a reference and I'll read something else, and that's fine. But write down your ideas when you think of them, because you might not remember them, a couple of days later. And we all have, iPads or whatever. It's not hard to do. I'll be out somewhere at a restaurant. I'll whip out my iPad and I'll make a little notation to myself. Also, you're going to be doing a lot of reading. You can summarize the relevant aspect of articles as you read them. So you might be able to read the whole paper, and then there's only a part of it that might apply to your study that you might use in either the introduction or the discussion. Well, summarize that paper right after you read it when it's fresh in your mind. And then later you'll have a whole bunch of really succinct statements about all your references that you can weave into your introduction or your discussion. And this is another thing, write forward. So initially, get the ideas down, get the statements down, don't fixate on the grammar, don't keep going back and fixing sentences and everything else. You do that later, okay? Try and write a whole paragraph and then come back. Now, what I do is I come back to a manuscript. I'll work hard on a manuscript for a day or so, and I might put it aside and work on something else. Every time I come back to that manuscript, I start from the very beginning, and I read all the way through, and I change, and I polish, and I change, and I rearrange, and I make the flow better, the sentences more concise. The first time I published as a graduate student, I was a master's student. And I was very ambitious. I took a class project and I tried to publish in Oikos. And it was only a page and a half in the journal. But I'll tell you, I edited it and re-edited that thing 50 times or more. Didn't even have any original data. It was just a verbal concept development. And when it was accepted, I will tell you, no one changed a single word or suggested a single change to wording. I cannot emphasize the importance of rereading and editing your stuff. Edit, and re-edit. So I like to say that manuscripts go through a period of expansion where they grow, you add parts, you add references, sections get longer. Then as you go over and you read it, it should go through a period of contraction, okay? It should start to get smaller as you tighten up all the text, okay? And finally, there's no such thing as writer's block. There are only scientists who either lack the ideas, lack the discipline and perseverance to put those ideas down on paper. So with that, we have time perhaps for some discussion if there's any other points that people would like to bring up. One thing I didn't mention was choosing a journal. And as a student, you know, I would strongly recommend you to get guidance from your experienced supervisors and thesis advisors, because the choice of a journal is another very important thing. And so many people submit articles to my journal that don't even belong there, okay? And so the other thing is, if you're ambitious, as I said, and you choose a very, very high impact journal, very often you'll get reviewed by non-entomologists who, you know, so you have to, it's much harder if you go to these broad ecological journals. Now, you might have something with very broad implications. There's nothing wrong with aiming high, but be prepared to be reviewed by people who may not be as familiar with insect systems as you are. So that's all I have. If anyone else has any discussion, I guess we have a few minutes.
I have a question about the abstract.
Okay.
So you said in the abstract, there is no need of including some statistics. So can you?
Well, you can, when I say statistics, I mean like F and P values. You can talk about magnitude of effects, direction of effects, but do it verbally.
Okay.
You know, statistics is something that they always break up a sentence. That's why you want to get all those packed into the results. And in fact, if you have many statistical comparisons, you should create a table for those. Like if you have a big multifactorial ANOVA with 4 independent variables and all the interaction terms, that needs to go on the table. No one wants to read through that stuff in the text. It's going to detract from the impact of your results. So even in the text, if you've got a lot of statistics or a very complex statistical table to report, put it in a table, get it out of the text. And there's no place for them in the abstracts, really.
You mentioned that in the abstract we should always talk in past tense.
Yes.
Is that for the rest of the manuscript also?
Generally speaking, yes. So for example, materials and methods, this is all things that you did in past tense, okay? And speaking of past tense, people, well, usually non-English people, they don't distinguish well between the past perfect and the past simple. And if it's a simple action that was completed, you know, that you should use the simple past. And there are other such, you know, and so learn the difference between the different past tenses as well. But yes, absolutely. And then again, in results, these are results. All results should be reported in the past tense. As I said earlier, the only exception is sometimes when you're in a discussion, you might touch on a very well recognized or generally accepted fact, okay? And then you can use the present tense to talk about that in the right context. It's okay. But when you're reporting results, always stay in the past tense. Okay. If there's nothing further, I guess we can finish the class.